classroom viewing purposes later. So number one, this is from our notes yesterday. I think this was, what method was this? This was method 3? Yeah, method 3, from 2 points on the line. Jackson, Tina, stay with us here. So, obviously you guys don't have red pens. Just add in any information that you're lacking and make any necessary corrections that you need if you were able to get through these problems, just like always. We got to start first by finding the slope. We've got 2 points here. Neither of them are our y-intercept. So the first thing we have to do is find our slope using the slope formula. y2 minus y1 over x2 minus x1. This is not something that you need to memorize. It's right here. We wrote it down yesterday, and you can use your notes on the test. So just follow this method. If you see, oh, okay, I've got a point here and a point there, what method do I use? Oh, the method that's writing an equation from 2 points, just like this, right? This is why we're able to use our notes on the test. So you can reference back to our different methods, plug in the numbers, and figure it out. So whenever we do the slope formula, the first thing we have to do is label our points. From left to right, we've got x1, y1. It's our first x coordinate and our first y coordinate. And then we've got x2, y2. So 4 different variables, 4 different numbers. We're going to plug those in exactly where they go and solve it out. So we're going to open up some parentheses here. y2 is 6, so that's going to go first. Minus y1, which is 2, over x2, which is 5. Question, Devin? Okay, let's focus up here, not over there. Minus x1, which is 4. All right? No negative numbers to worry about. Bless you, bless you. This makes our life easier. 6 minus 2 on the top gives me what? 4, thank you. What about 5 minus 4? What's that? 1, thank you. Now, when we have this fraction here, what do we need to do with these numbers? Are we going to add, subtract, multiply, or divide, Darius?
Divide.
Divide, exactly. 4 divided by 1 is just 4. All right? Don't want to accidentally add them together and get 5 or subtract them down and get 3. Anytime we have 2 numbers in a fraction, we are dividing. All right, so there's the first part. Our slope that we found is 4. We're going to write that down on the bottom. M is equal to 4. Now that we have the slope, we're going to take our first point, 4, 2, and we're going to plug them into our equation. B is equal to y minus m times x. It's just our reformatted slope-intercept formula, also known as boy, yo, mama's x, right? We're going to plug in a y, an m, and an x. So I'm going to take out those just like we did with the slope formula. We replace those variables with open parentheses and plug in our 3 specific parts. So what number am I going to plug in for y here from my first point? The 4 or the 2?
The 2?
The 2, right? We labeled 2 as my y1, so that's what we're going to plug in for y, is 2. What number should I plug in for m? 4. That's what we just found in the first step. And what can I plug in for x? 4 again. My x1 that we labeled was 4. So I'm going to plug in my second 4 right there. Following PEMDAS, should we subtract 2 minus 4 first? Or should we multiply 4 times 4 first? Multiply. What is 4 times 4? 16. Bring down the 2. Bring down the minus. And 2 minus 16 is going to give us what?
-14.
Beautiful. Look at that. That was like the most answers at once I've heard all year. Minus 14. And that's our B. Love hearing that. That's great. So M is 4, B is -14. My equation, y equals mx plus b. Yo, mama's ex-boyfriend. is y is equal to, what was my m?
4.
4. X, what's my b? Negative 14. Boom. There's my equation. 3 steps. Find the slope using the slope formula. Find the b by using our restructured slope-intercept form. And then once you have m and have b, you just plug them into our equation. Oops. There we go. I'm going to make it brighter. I know this was the worksheet that we got with the substitute on Tuesday, so is there any questions I could answer about that? Feeling okay? Hopefully. Again, from our notes yesterday, that was method 3. Oops. Method 3. Everyone should have these notes from yesterday. If you weren't here yesterday, the video's in Google Classroom. Just copy them down at home tonight because it's going to be almost as helpful as this study guide is going to be when it comes to our test tomorrow. Number 2, this is method 2 from our notes, a slope and a point on the line. We basically do the same thing we did in number 1 without all this slope formula work because it says a line with a slope of 3. So what is my m going to be equal to here? 3. That's nice and simple. M is 3. What's my x going to be here between 3 and 2? What's x? 3 is my x, which means 2 must be my y. Same formula. Boy, yo, mama's x. B is equal to something minus something times something. What should I plug in for y? 2. What about m? 3. And my x? 3 again. Again, following PEMDAS, we want to multiply first. 3 times 3 gives me 9. And what would 2 minus 9 give us? Negative 7. That's right. And that's my b. This was method 2 again. So if m is 3, b is negative 7, my equation is y is equal to 3x minus 7. Just plugging them in, m for m, b for b. Question? Sure. All right. Questions I can answer about number 2? Thumbs up if that sounds good to you. Excuse me. Okay, 3 thumbs up. That's all right. I'm assuming there's more. So, number 3, real world context here. Let's try and understand it. You can eat 6 Takis per minute. You guys can probably eat more than that, but for this problem, you can eat 6 Takis per minute. Fill in the table and write the equation. Right? So, X is my number of minutes. Y is my number of Takis. Our problem tells us, and this is where a couple people had some confusion yesterday. I got a lot of questions about this. 6 Takis per minute. So let's ignore the 0 for a second. After 1 minute, how many Takis could you eat?
6.
6. Thank you, Jaren. 6. Right? So after 0 minutes, how many Takis would you be able to eat? 0. I had a lot of people plugging in 6 in my first box and then moving it along. But if no time has passed, then you're not able to eat any Takis, right? 1 minute, you can eat 6. How many can you eat after 2 minutes? 12. What about 3 minutes? 18. What's the pattern here from point to point? Plus 6. So finally, after 4 minutes, we can eat 24 Takis. Plus 6 on the bottom. What's my change in X on the top? Plus 1. Plus 1. Plus 1. So my M is the change in Y over the change in X. 6 over 1. What does that simplify to? Just 6. So my M is 6. And this is what we talked about last unit with that lesson about unit rate, right? Unit rate is just a fancy term for slope within a certain context, this context being Talkie consumption. We're eating 6 Talkies per 1 minute. A unit rate means that our second quantity is always 1. So we know right away that 6 is going to be our M. That's our unit rate. But what's my B going to be here? What is B equal to? 0. We see on the table that an X value of 0 gives us a Y value of 0. So B is equal to 0. For my equation, I'm going to write Y is equal to what? Can someone help me out? 6x. We could say minus 0. We could say plus 0. But do we need to put that at all? No. We can just leave it as Y is equal to 6x. This would be a proportional relationship because after 0 minutes, you've eaten 0 Talkies. Now, if this question said you just ate 10 Talkies, from there, every minute you can eat 6. Well, now you have a starting value of 10, and you add 6 each time. But all it says is you can eat 6 Talkies per minute. So after 0 minutes, you've eaten 0 Talkies. Does that make a little sense? Okay, hopefully it does. Number 4, this is just like our Keurig coffee maker problem from yesterday. A popcorn machine costs $60 to buy. Each serving of popcorn that you pop costs $1.50 per serving. Complete the table below and write the equation. So X is my number of servings. Y, as always, is my total cost. So after 0 servings of popcorn popped, how much have you spent in total? $60, right? You got to buy the popcorn machine first. That's where this problem differs from number 3. You have a starting value of 60. Right away we see, 0, 60. What's my B going to be equal to here? 60. So we spent $60 on the machine itself. We just popped 1 bag of popcorn, which cost me $1.50. So how much have we spent in this second box in total? 61.50. I'm going to call that 61.5. As we can see, that's a change of 1.5 over a change of plus 1. Which means that my M is going to be equal to what? 1.5. Again, with a word problem like this, like we talked about on Monday, there's 2 numbers that they give you, 60 and 1.5. One of those numbers you only have to buy once, the machine. One of those, the other number you have to pay repeatedly over and over. Every time you pop a bag of popcorn, $1.50, $1.50, $1.50. So what would my next Y value in the table be? $63. What's going to come after 63? 64.5. And finally, my last Y value? $66. And those are all plus 1.5 plus 1.5. My equation, Y is equal to 1.5x plus 60. And what this equation represents, again, Y is the total cost. So you're paying $1.50 times however many bags of popcorn you eat, plus that initial payment of $60 for the machine itself. Sound good on number 4? Questions I could answer? Stephanie said? No, okay. Number 5 is nice and simple. We're going to breeze through number 5 because this was actually on our last test as well. Find M and B for each equation. Well, if Y is equal to mx plus b, whatever number's in front of x is our M. Whatever number's being added or subtracted on the end, that's our B. So in 5a, Y is equal to negative 2x plus 3, m is negative 2, b is positive 3. Right? Seems like we've been talking about this all year because it's been, I don't know, 4 or 5 weeks that we've been talking about m and b. Spoiler alert, our next unit is the same kind of stuff. Lots of m and b and equations and all that still. In 5b, my m is 1/2, my b is going to be 4. Yes?
Negative.
Good catch. Negative 4. I wanted to see if anyone could grab that. Whenever we're minusing a number in our equation, that means we have a b value that's negative. Again, b is our y-intercept, so that shows that we're intercepting or crossing the y-axis in our negative section, below the origin. Now I can see in 5c that my b is 10, but I don't see a value for m. All I see is a minus sign. So is my m just going to be minus?
No.
What's my m going to be? Negative 1, right? That's our invisible 1 in front of that x that we don't really see, but we always know is there. So m is negative 1, b is positive 10. Questions I could answer about finding m and b? It's just identifying, no math involved there. Down to 6. Now this was another area where we had a lot of questions. So I saw some people saying, oh, these are not linear because they don't go through the origin. Now, I love that thinking, but you're thinking of proportional. Proportional relationships have to go through 0, 0. But for a relationship to be linear, we need a constant change in y over a constant change in x. Essentially what that means is that when we do our little arrows from point to point, we should get the same number across the top and the same number across the bottom. So on the top, how would we get from 0 to 2? Plus 2. What about from 2 to 4? Plus 2. And 4 to 6? Plus 2. Is that a constant change in x on the top? Plus 2, plus 2, plus 2. Is that the same number?
Yes, 2 plus 2.
Yes, 2, 2, and 2 are all the same number. Let's go to the bottom. How do we get from 20 to 24?
Plus 4.
Plus 4. What about 24 to 28?
Plus 4.
And 28 to 32?
Plus 4.
Are those all the same number?
Yes.
Yes, they are. Therefore, this is linear. It's not proportional because it goes through the point 0, 20. But if we graphed these points, we'd be going up 4 over 2, up 4 over 2, up 4 over 2. That constant change makes a straight line, which is linear, right? Line is right there in the word. Now that we know that, let's look at number 7. For number 7, how would we get from 0 to 2?
Plus 2.
What about from 2 to 3?
Plus 1.
Plus 1. What about from 3 to 4?
Plus 1.
Plus 1. So right away, that doesn't work out. But let's check the bottom. How do we get from 5 to 10?
Plus 5.
Plus 5. What about from 10 to 18?
Plus 8.
Plus 8. And from 18 to 23?
Plus 5.
Plus 5. Is that a constant change on the bottom?
No.
Definitely not. Those are all different numbers. If we plotted these points, we'd be going up 5 over 2, then up 8 over 1. So let's say we're starting here. We go up 5 over 2, up 8 over 1, and then up 5 over 1. That's going to make like this kind of curved line that is definitely not linear. Thank you, Jack. We're just going over the study guide right now. Did you get it yesterday? You did, right?
Yeah.
Okay. Nicholas, Darius, go ahead and head back to where you're supposed to be. Thank you. Might help your focus even, either way. Right. So that's how we determine whether a graph, or not a graph, a table is linear or not linear. All right? Questions I can answer about that? Give me a thumbs up if that makes sense. Just do your arrows. If it's the same number, it's linear. If it's different numbers, it's not linear. All right, to the back, because the back is hefty. We got 15 minutes. Starting with number 8. Lots of real-life situations here on the back. The temperature of your heated pool decreases throughout the day, as shown in the table below. Write the equation. So this is just writing an equation from a table. Good morning, sir. Writing an equation from a table is method 5 from our notes yesterday. So if you see a table on the test and you're told to write an equation, look at method 5. You can take a seat right there. Yeah, that's fine. Okay. You gotta get through this, so I gotta go. There's a lot to get through. So number 8, temperature of a heated pool decreases. So we're going to do our arrows on the top from 0 to 1. How do we get from 0 to 1? Plus 1. From 1 to 2, plus 1. From 2 to 3, plus 1. Now we're missing a value here, but let's figure out the pattern first and we can work our way back. How do we get from 90 to 87? Minus 3. What about 87 to 84? Minus 3. So from left to right, if we're doing minus 3, and we go the opposite direction, right to left, we're going to do plus 3, which gives us 93. So understanding the context here. As soon as, well, let's say at the height of the day, your pool temperature is 93 degrees. After 1 hour, it decreases to 90 degrees. After another hour, it's down to 87. After another hour, it's down to 84. Just out of curiosity, what would the next Y value here be? 81, right? We're decreasing left to right. That would be after 4 hours. Not that that matters, but I just wanted to see. So my M is going to be negative 3 over positive 1. What does that simplify to? Negative 3. That's my M. Is there a B visible on this table somewhere? 93. Anytime we see an X value of 0, the Y value below it tells us our B, which in this case is 93. So what's the equation that we could write here? Y is equal to what? Negative 3x plus 93. Exactly. Okay. Now, laser tag. Anyone ever been laser tagging before? Couple people. I never have. It looks kind of scary. Do you get hurt in laser tag?
No. I usually fail at it.
Breeza's saying yes, you do get hurt.
How do you get hurt? It's laser.
You just point little like beams, right?
Yeah, but it's no laser.
Oh, if you fall. Oh, that's true. Yeah, I'd probably fall in the dark. I can't go do all that. I think the 8th graders went on like a little laser tagging trip last year, if I remember. It was like bowling alley laser tag. Anyway, sorry, I went a little off track there. But this is like our bowling alley problem, right? A laser tag arena charges $7 to rent the equipment, just like the bowling alley charges to rent the shoes, plus $3.50 per game played. Again, just like our bowling alley. Fill out the table, write the equation. So X is our number of games, Y is our total spent. After 0 games of laser tag, how much have you spent in total? Don't say 0. How much is the equipment? $7. Right? Like I've been saying, one of these numbers is our M, one of these numbers is our B. One of these things only happens once. Do you rent the equipment multiple times while you're at the laser tag place? No, you only have to do that once. So we know right away 7 is our B. But if you go there and plan on playing 3 games, you're going to pay $350, then $350, then $350, over and over and over, right? So $7 for the equipment, $3.50 for the first game. What's your total there? 10.50 or 10.5. That's a change of plus 3.5 over plus 1. So 3.5 is my slope or my M. How much would 2 games cost in total?
13.5.
Close.
14.
14. Right? 10.5, if we add the 0.5, that makes 11. 11 plus 3 is 14. And then my last 3 games, 14 plus 3.5. Well, what would 14 plus 3 be? 17. So just throw a 0.5. 17.5. These 50-cent questions are a little bit tricky because we don't really work with decimals a whole lot in here, but what are you doing?
That's 18.
But you will have to do this very similar process on the test, adding 0.5, okay? So your equation, M is 3.5, B is 7, Y is equal to 3.5x plus 7. Boom. Questions I can answer about that? Okay. 10 is there's a lot going on in number 10. So let's break this down. So this graph here shows the linear relationship between the number of months that you're depositing money and the total balance in your savings account, including the initial deposit. So just by looking at this line, what's the y-intercept? Where do we cross this y-axis with this line? 200, right here. That's our y-intercept, right? Here's my y-axis. We intercepted at that point at 200. So that's my B. Now you're going to have to interpret the meaning of that number. And by interpret the meaning, it means explain in words what that $200 represents. So if we're talking about a savings account, right? And you've got $200 in it after 0 weeks, what does that y-intercept mean? Anyone want to interpret that real quick for us? What would it mean if 200 is our starting value? You begin there, right? So if we're talking about the context, right? The y-intercept just means you start with $200 in the account, right? All interpret ACCOUNT. All interpret the meaning means is give some context to these numbers, okay? The slope of the line, if we do rise over run, we're going up 100 over 1, up 100 over 1. So our M is 100 over 1. That just equals 100. So if there's $100 being added into your account after 1 month, and then another 100 after 2 months, what does that mean? Well, it means that you are depositing, which means putting money in, depositing $100 each month. Simple as that, right? And that's something that I know you guys understand in your heads. It's just a little bit more difficult putting it in writing, yes? But reading this problem and looking at that graph and analyzing our problem, you know that that's what we're talking about. It's just kind of putting it down in writing is the difficult part. So our equation, y is equal to 100x plus 200. There's our equation. Questions I can answer about that? Does that make a little sense? Yes. How did I get 100? Perfect. So whenever we have a graph, right, and we want to find the slope, we just do rise over run. So from point to point, we rise up from I'm just going to take this random point here. We're going up 1 square, but on my y-axis, 1 square is worth $100. From 500 to 600, that's 100. And then we run over 1 from 3 months to 4 months. So this is a change of 100 units up and 1 unit to the right. Rise over run, 100 over 1. Does that make sense? Great question. Kind of breezed through that, so that didn't make sense. Number 11, this is kind of like review from our last unit 2. Where does this line cross the y-axis in number 11? -3 right there. So B is -3. And just like I said with the last one, to find the slope, we got to do rise over run. Starting at our left point, working towards our right point. We rise 1, 2, 3 spaces up, and we run 1, 2, 3, 4 spaces to the right. So what's my slope going to be? 3 over 4. Rise over run. Y is equal to 3/4 x minus 3. We didn't talk about that too much this unit because it was our main focus in unit 3, but it's all connected. Number 12, we got to do a little bit more work with this graph here. First things first, we got to plot these points. 0, -4 right there. Right away, we know that B is -4 because that's on the y-axis. And then we've got +4, +3 right there. You can connect those points to make a line. And again, we do rise over run. We're rising up 1, 2, 3, 4, 5, 6, 7 spaces up. 1, 2, 3, 4 spaces to the right. Rise over run is 7 over 4. My equation is y is equal to 7 over 4 x minus 4. Oops. So on one, you'll start with the graph, figure it out. The other one, you'll just start with the points, have to graph it, and then figure it out. So a little bit more difficult in that second one. Last but not least, this is like how we did on the notes yesterday. We've got some missing squares on your graph here. So all you have to do is follow the pattern to get those squares filled out. We're comparing the weeks, number of weeks after planting a sunflower versus the height of the sunflower in inches. So what's my change in x on the top from 0 to 2, 2 to 4, and 4 to 6? Plus 2, plus 2, plus 2. What's my next number of weeks? 8, because we're just plus 2. Change in y on the bottom. How do we get from 8 to 14? Adding 6. So what's my next y value? 20. And my next y value after that? 26. Now if we're adding 6 to the right, what are we going to do to the left? Subtract 6. 8 minus 6 gives me 2. What does that 2 mean there? What's that? 2 is our B. Great. 0, 2. B is equal to 2. In the context of this problem, it means the sunflower was 2 inches tall right when we planted it. So we didn't plant it as a seed. We planted it when it was 2 inches tall. What's my M here going to be? Yes. Yeah. How'd you get 3? 6 over 2. Exactly. Right, or change in y of 6 over change in x of 2 gives me 3. My equation is y is equal to 3x plus 2. I know we kind of sped through that there at the end just to get out of here on time, but like I said, this video is going to be in Google Classroom. I highly recommend